Alright, so today we're going to be going over some formulas for the fluids and heat unit. But first off, we need some music playing in the background, to um, just for some background music, to go along with the formulas. So, yeah. Alright, so the first formula is the average molecular kinetic energy. So that equals 3/2 kb times the change in temperature, and the kinetic energy also equals nr times the change in temperature, and kb is actually the Boltzmann's constant. That is 1.38 times 10 to the negative 23rd joules over k. So n equals the number of moles, R equals 0.0821 liters times ATM over K times moles. Next formula is the first law of thermodynamics. The change in energy equals Q plus W. Q is heat in joules, and W is the work in joules also. Next formula, pressure from depth. P equals F over A, and F equals the force, A equals the area in meters per second. Now the maximum efficiency of a heat engine. That equals the hot temperature minus the cold temperature over the hot temperature. Archimedes / buoyant force, or F buoy, equals PVG, and P equals density, and that is kilograms over meters cubed. V equals velocity, meters per second, and G is gravity. And last formula is the ideal gas law, Pvnert. PV equals nRT.
Okay, so this is the pressure formula, and the pressure formula is P in pascals equals PO, pressure at surface, plus small p, density, times gravity, which is 9.8, times height in meters. Next formula is heat expansion. Heat expansion equals angular acceleration times length times total temperature. The next equation is continuity. So basically the continuity equation states that a rate in which the mass enters the system is the same as the rate in which a mass leaves the system. So like water going from a smaller pipe to a bigger pipe. And the continuity equation is the first area times the first velocity equals the second area times the second velocity. So the next equation is Bernoulli's. Now this is a pretty long equation, but when you actually use it in a problem, it ends up being really short because a lot of things cancel out. So Bernoulli's equation is pressure plus density times gravity times the first height plus 1/2 density times the first velocity squared equals pressure plus density times gravity times the second height plus 1/2 times pressure times the second velocity squared. This is a heat flow formula. So H, heat flow, equals thermal conductivity times area times total temperature divided by length. Now, one easy way to remember this is cattle, like a bunch of cows. H equals cattle.
All right, snack time. I've got me a drumstick, crunch dipped vanilla. These are really good. Best ice cream you'll ever have. The reason I like these, if I can open this, the reason I like these is because of the peanuts, the so-called peanuts on the cone, or on the chocolate, I mean. But they're actually not peanuts. There used to be peanuts on the chocolate, but now there's not. I don't know why. I guess, the companies just get greedy, so they skip out on the peanuts. But I still like it because it still has a crunch. So yeah, if you wanna go pick up some ice cream, go get some drumsticks. You'll like them. Some of them have fudge inside the core. Yeah, fudge, caramel, or just the vanilla, if you just like vanilla and chocolate. So yeah. Okay, so now we're going to be doing the unit problem on heat and engines. So a 0.03 mole sample of helium is taken through the cycle shown in the diagram above. In one complete cycle, the work is negative 500 joules. From C to A, 100 joules of energy is removed from the cylinder. So right here, this PV graph goes from A to B to C. So it's actually going clockwise, which means it's an engine. So it's going up right here, and then down, and then back to A, B, and then C. So for A, part A, it's asking us to find the temperature at state A. So what we want to do is use the Pvnert formula. And we can do that by plugging in 1 times 10 to the 5th times 0.001. And that is pressure times velocity, 1 times 10 to the 5th ATMs times 0.001 in meters cubed. Okay, so, and then N, that's the number of moles, so that's going to be 0.03. It actually gave us this right here, 0.03 moles, and then times 8.31 joules per mole times K times K, and then times the temperature. And R, that is the that equals 8.31 joules over moles times K. That is the constant for R. Okay, so now we're just gonna go up here, and once we do all that multiplication, we end up with 0.001 equals 0.2493 times temperature. Okay. So now once we divide that by 0.2493, we end up with 0.0040 112314. Okay. And so we're not done yet. We want the pressure in pascals, so we're gonna have to do some cross multiplying and make the pressure end up in pascals. So we're gonna go back up here. So 1 ATM times 1 times 10 to the 5th pascals over 1 ATM equals 1 times 10 to the 5th pascals. So, okay, so now the temperature equals, we'll put the temperature over here, the temperature equals 401.0